So let's get to a couple of these examples. The more you practice them, the better you're going to get at them. You're going to start to notice certain things that happen every single time with the proofs. So it's all about practice. So with this, what I did was I already took all of the givens and stuck them down here to save some time so that the videos aren't long. And then what you want to do when you start a proof is mark everything they give you. So we've got AB is congruent to ED. Then they tell you C is the midpoint of this bottom line. So that means it's right in the middle. And then they tell me AB and BD, these two lines are perpendicular, and that these two lines are perpendicular. So those are the givens. So I can't really mark a whole lot in my picture. To be able to prove that two triangles are congruent, you're probably going to need a couple more pieces of info. So 2 more pieces of info. Use them from the givens. That's why the givens are there. So C is the midpoint. What that means is it's right in the middle of this line. So that means these two will be equal. That's what you want your next step to be. So segment BC is congruent to segment CD. The reason why we knew that is because they told us it was the midpoint. So this is a definition of a midpoint. Okay, still need more info. I only have 2 pieces of info. So now use the given where it tells you lines are perpendicular. So when lines are perpendicular, what that does is it forms 90-degree angles. So that's what my next step is going to be. We're going to say angle B is angle B and angle D are right angles. Okay, and the reason why we knew that they were right angles is because these lines were perpendicular. So that's just going to be definition of perpendicular lines. That's what perpendicular lines tell me is you're going to have 90-degree angles. Then your next step, you want to tell me, obviously, we need to know sets of things that are equal. So now you can say angle B is congruent to angle D. And the reason for that is because they're both right angles. So this one, you can just say all right angles are congruent. So I'm shortening a lot of this, which is fine. You can do the same thing. All right angles are congruent. I'm doing it so it'll fit because my picture's in the way. So now I have 3 pieces of information. Once you have that, you can go straight to your triangle congruence statement. Most of the time, it'll be the proof part. If it's not, then you have to make your own triangle congruence statement, okay? So most of the time, it will be the proof part. So I can write that down here in step 7. Don't ever use the word prove, though, on either side. So over here, the reason my 3 pieces of info show me, usually I tell you look for HL with the right angle, but if you look at your hypotenuse, it's not marked. So I do have side, angle, side. The angle is included for this one. So anytime you get a triangle congruence statement, make sure you use one of those postulates. If the proof part is something else, then the prove would go next. And then that's always, anytime something follows the triangle congruence statement, it is always corresponding parts of congruent triangles are congruent. CP, TCT. Okay? So that one was a pretty tough one. But anytime you see something about a midpoint, midpoints, you're going to be using congruent segments. If you have perpendicular lines, you're going to be using those right angles. So it's a bunch of things that happen, but they all have the same result. So when you see bisect, that means something's going to be equal because something got bisected. So always start with the givens and then always start marking your picture. I've got AB and AC. Then it tells me that AD bisects this. So that's where my next piece of info is going to come from. If it bisects this, it cuts it into 2 equal parts. So that's what my next step is going to be. So you want to use the givens to find out what happens next. The reason why we knew that is because it was bisected. So this is definition of a segment bisector. Oops. And please put the segment part, whether it's a segment bisector, an angle bisector. I want to see that part. Okay, now I still don't have enough. And the givens don't tell me anything else. So I need to look for a hidden piece of info like vertical angles, shared sides, parallel lines, that kind of thing. Right here, it's a shared side. So if you have a shared side, you can put that. I've got segment AD. It's congruent to segment AD. If you have a shared side or a shared angle, it's always equal to itself, and it's always the reflexive property. In this case, reflexive of congruence, I won't make a big deal about that. So I've got my 3 pieces of info, which means my next thing is the triangle congruence statement. It's the proof part, So that's easy. I can just copy. And then my postulate, I've got 3 sets of congruent sides, so that is SSS. All right, next, I've got my 2 givens. I put them over here. There's my givens. Let's mark it. So it says C is the midpoint. So that's the midpoint of DB. That'll help me for step 3. And then angle ACB, which is right here, is congruent to angle ACD, this one right here. So that's my given stuff. Use the other given that hasn't told me anything yet. It's a midpoint, so that means it's right in the middle. That means if C is in the middle of that, those two are going to be equal. So mark that. DC is congruent to CB. The reason why we knew that is because it told me it was the midpoint. So this is definition of a midpoint. I ran out of room. Okay, so that's all I got. That's all I can get from my givens. So I only have 2 pieces of info. There's no vertical angles, but I do have a shared side in the middle. So segment AC is congruent to AC. Okay, shared side, shared angles, those are always reflexive. Got my 3 pieces of info, so next will be a triangle congruence statement, which is right there. That's the proof. So just copy. And then I've got side, angle, side for that one. Okay, I think I got 2 more for you, and that's it. All right, next. Here's my givens. They were over here. So L is the midpoint of WE. So L right there, that's going to be the midpoint of this line, which means it's going to be right in the middle. They also tell me that you've got 2 sets of parallel lines. So they didn't give me anything that's equal. I'm going to have kids coming in, but that's okay. Okay. So my next one, I've got WR and ED that are parallel, so they're not equal. So you have to figure out what that means. So if I have 2 parallel lines, what I can do is mark a transversal. Okay, you can let them in, Kim. I don't care. So that means these 2 angles are going to be equal. So that's going to be my next step. So I've got angle WRL and EDL. Okay, the reason why those were equal, we had parallel lines, so those are alternate interior angles. Okay, same thing if you use the other transversal. Now, if I use the other transversal, that means these 2 blue ones are equal. So that could be my next step. So I've got RWL, and I've also got DEL. And those are also alternate interior angles. Okay. And then the other thing I had, I know I have vertical angles in there, but there's no postulate AAA. So I don't want to use that, number 1. Number 2, I want to use the stuff they give me in the givens. So if L was the midpoint of this, that means these 2 are equal. So that's what I want to use for my next one. So segment WL will be congruent to LE. Okay. And then that is because this was a midpoint. So I got definition of a midpoint. Okay, got my 3 pieces of info. So the next thing I want is a triangle congruence statement right there. It's my prove part. So to save time, since the bell rang, I'm just going to do this. And then my postulate, I've got 2 angles and a side that is not included. So that is angle, angle, side. Okay, last one. I've got NKL. So NKL, that's this angle. And NJM, that's this angle. So that's given. KL, which is a little harder to mark, so I'm going to highlight it. KL and JM, those 2 are equal. That's all they give me. So I need another piece of info. Look for those invisibles like a shared side, vertical angles, things like that. Right here, what I'm going to want is the shared angle at angle N. So in that case, I'm going to mark it as angle N is congruent to angle N, and that's going to be reflexive. So now I've got my 3 pieces of info. Now to do my triangles, I'm going to need this triangle. And I'm going to need this triangle. So I need the red one and the blue one. So since I have my 3 pieces of information, I'm going to go to a triangle congruence statement. The red one is JNM. And the blue one is LNK. Okay, those two are, let me get rid of that. Hold on. Those two are congruent, and I've got 2 sets of angles and 1 non-included side. So the 1 non-included side, that means I'm going to have angle, angle, side. Okay, so once you have your congruent statement, then you can do your prove. If it's not a congruent statement, it comes last. So I've got segment LN and segment MN. And that's always corresponding parts. So congruent triangles are congruent. Okay, so work on your worksheet. Good luck.